We're going to go through an example right now dealing with a hodograph that is going to look something like this. We'll have southerly flow, we'll have southerly flow up high over here, and then down low we'll be dealing with northerly flow. So northerly flow down low, and then southerly flow in the high levels over here. So a hodograph that looks something like this. And in this particular case, kind of performing the same analysis that we did last time, looking at where the maximum of sorts of this parabola, of this curved hodograph is. It's going to be somewhere along the x-axis here, so I'll mark that with a dashed line as such. And the consistent shear profile sign, consistent sign of the shear profile is going to be associated with, in this case, partial V bar, partial Z, because at every single point in the hodograph going up in the atmosphere, V bar is always going to be increasing. We go from large values of negative meridional motion to large positive values of meridional motion, and we're always dealing with increasing values of meridional motion throughout the profile. So over here, partial V bar, partial Z is going to be greater than 0. Partial V bar, partial Z is going to be greater than 0 up high as well. And in the case of the partial U bar, partial Z, in the low levels of the atmosphere over here, we're starting out with 0 zonal motion, which is going to be increasing up to this maximum, the parabola function over here. And then as we go further aloft in the atmosphere, we'll be dealing with decreasing values of U bar. So partial U bar, partial Z is going to be less than 0 farther up in the atmosphere. So let's start out with the analysis of this hodograph, starting with the consistent sign of the shear profile, in that case corresponding to partial V bar, partial Z, or down this hodograph, or along this hodograph over here. So we're going to start out by performing an analysis along the deep shear vector, which is going to be, in this case, I'll just call this deep shear vector over here, and then the corresponding horizontal vorticity will be using the right-hand rule to the left of that. So let's start out by drawing our Cartesian coordinate system over here, x, z, y. And we know that in this particular case, we'll have our initial updraft develop along this zonally oriented horizontal vortex tube. It'll be tilted to the vertical. We've got flanking west and east in this case, left and right, new updraft. So here will be our initial updraft along the x-axis. And then I'm not drawing into the page, I'm drawing west-east along the page, our flanking new updrafts over here that are co-located with vertical vorticity that has been tilted into the vertical. That's all associated with those initial processes that we talked about earlier. Once we have the updraft acting on the horizontal vorticity. And we're now going to perform an analysis along the deep shear vector. So for each of these updrafts, we're going to look down the shear vector. Excuse me, I should say updrafts. I believe I said that. This is the ground over here. Let's just do the analysis for one of the updrafts, since we know that we're going to be dealing with the consistent sign of the vertical shear term over here. So in the mid-levels, we're going to be dealing with partial V bar, partial Z times partial W prime, partial Y. As we're approaching each of the individual updrafts, and then as we're going away from them in the positive Y direction, partial V bar, partial Z, partial W prime, partial Y. In this case, as we're going toward the updrafts, positive, going away from the updrafts will be negative, and then everywhere, and again this is in the mid-levels, and then everywhere partial V bar, partial Z is going to be positive on both sides over there. So the result is going to be, in mid-level, positive perturbation pressure associated with linear effects, up shear and then down shear. We're going to be associated with negative perturbation pressure associated with linear effects. And so that is going to be resulting in induced vertical motion that is downward, up shear, and then upward, down shear like that, which is going to result in these cells developing down the shear vector, as we talked about, associated with the consistent sign component of the vertical shear profile, partial V bar, partial Z. And so neither of these new updrafts, neither one is going to be favored. Everything will be advancing down shear. But at this point, we're going to now have to consider the effect of the alternating shear profile term as well, since this also needs to be considered in this case, given the fact that partial U bar, partial Z changes sign from the low levels of positive to negative in the higher levels. So let's now perform the analysis along our horizontal vortex tube in the x direction. So initially the analysis was, in this case, going to be along the deep shear vector. Now we're going to be considering along the vortex tubes. It's going to be effectively looking at the effects of the curved hodograph over here. And so let's redraw our initial updraft over here, our flanking updrafts over here. And we'll consider this along the vortex tubes, along the x-axis. And we know that in the case of our vortex tubes, again, let's see, our vortex tubes, vortex lines, I should say, or vorticity vector in the horizontal is pointed towards the west. So when that's tilted into the vertical, that's going to be associated with negative vorticity to the left and positive vorticity to the right over here, relative to the deep shear vector. And so at this point, we're going to consider the analysis above and below each of those individual new updrafts that are developing on the flanks of this initial updraft. And we're going to consider again the analysis along the x-axis, such that we have partial U bar, partial Z, partial W prime, partial X. To the left, we're going to consider partial U bar, partial Z, partial W prime, partial X. Partial U bar, partial Z, partial W prime, partial X, and partial U bar, partial Z, partial W prime, partial X. Here's the ground down low. And as we go in the x direction towards this updraft over here, we're going to be associated with a positive, we're going to have a positive value, partial W prime, partial X, no matter where you're coming from, looking in this case from the left to the right. And then as we're going farther, in this case to the east of this right flanking member over here, we're going to have negative values of partial W, partial X, and negative values of that same term over here as we are having increasing displacements into relatively lesser values of upward motion related to the right flanking updraft over here. And then partial U bar, partial Z, that comes right out of the analysis over here. In the low levels, we're dealing with positive values of that term over here. And then in the high levels, associated with the alternating shear profile, that's what's special about this case over here. With the curved hodograph, we have negative values. So the result is going to be positive linear perturbation pressure down low for the left member, negative over here for the left member higher in the atmosphere, negative for the right member in the low levels, positive for the right member relative to the deep shear vector in the high levels, inducing a perturbation pressure gradient force that is directed upward for the left member over here, and then downward from positive to negative for the right member, as you can see over here, and that is going to suppress the right of the initial updraft relative to the deep shear vector flanking cell, and enhance the left of the initial updraft flanking member relative to the deep shear cell developing over here, and the net result is going to be the left dominant meso-anticyclone. That's going to be the side of the initial updraft that is the same side as the hodograph here with concavity relative to the deep shear or to the left. And so in this case, the deep shear vector is going to be associated with down shear propagation from south to north, whereas the left deviant motion is going to be associated with some tendency for the cells to move more toward the west. So we're going to have generally net southeast to northwest motion of the left mover in this particular case, that is going to be associated with a meso-anticyclone. For this particular example,